Well, good morning and welcome to Advanced Math class and Lesson 77, Binomial Expansions. This is not one of the easiest lessons in my opinion. I tried to do a really careful job explaining it, so maybe it will be easy this year. I will just say that we're going to study something produced by a guy named Pascal who was ridiculously brilliant. I may have told you this story, but Pascal was the kid who spent so much time on his math books that his father took away his math books to try to get him to do something besides math. So he wrote his own math textbook. So this is the kind of guy behind this. Now, that doesn't mean this is actually that complicated. In fact, I'm really glad the guy was this brilliant because he figured something out that helps us. Okay, so we have a problem like this. This is called expanding binomials. We're going to multiply a plus b 8 times. Okay, nobody wants to do that. You could. You obviously could. I almost guarantee you're going to make a stupid mistake somewhere in the process. Since you're going to be doing 7 multiplications, they're going to be longer and longer and longer as you go. So we really need a shortcut. And that's the point of this chapter, this lesson. So there are 3 parts to this, the a, the b, and the coefficients. Okay, so we're multiplying a plus b to a power. We're going to get an expression at the end that's going to be some number, a to an exponent, b to an exponent, plus another number, a, b, another number, a, b. Okay, we're going to have lots of terms, but there's going to be, in every term, you're going to have an a, a b, and a number. Okay, so a, b, and the coefficients. Now, when you do this, a will start with the highest exponent and go down to 0. So the first term, a will have the highest exponent. So for example, if we're doing a plus b to the 8th, and I'm using a large one just because it's big, and this works well for big ones that are hard to do any other way. The first term will have an a to the 8th in it, okay, because that's the highest exponent. 8 is the highest exponent. The first term will have a to the 8th in it. The second term will have an a to the 7th in it. The third term will have an a to the 6th in it. It just keeps going down until the last term has a to the 0. Now, a to the 0 is 1. When you multiply by 1, it's invisible. So you won't actually see a in the last term, but it is technically there as a to the 0. So that takes care of a. B, on the other hand, will start with a 0 exponent and go up to the highest exponent. So for the same example, in the first term, you'll have b to the 0. Now, b to the 0 is 1. 1 times anything is just whatever, so the 1 is invisible. So you won't see the b in the first term, but it's just technically there. The second term will have a b to the 1st in it. The third term will have a b squared in it. And they'll just keep getting larger and larger until you get to the last term, which has a b to the 8th in it. Okay, let me show you what this looks like. Combining those two things together. All right, so we're combining what I just said about a and b. You're going to have something that looks like this. Maybe you were having trouble with following where I was going. If so, now that you've seen this, you can go back and review the last couple of minutes. So the first term has a to the 8th, b to the 0, which you can't see. Second term, a to the 7th, b to the 1st. Third term, a to the 6th, b squared. Fourth term, a to the 5th, b cubed. Fifth term, a to the 4th, b to the 4th. Okay, and you're going on down then to the last two, a to the 1st, b to the 7th, and the last one, a to the 0, which you cannot see, and b to the 8th. Okay, do you see that pattern? Okay, the a's are going from 8 to 0, the b's are going from 0 to 8 on their exponents. And so this is a good, important, useful tool. That was too many adjectives. Sorry about that. Notice that the exponents in every term add up to 8. 8 and 0 is 8. 7 and 1. 6 and 2. 5 and 3. 4 and 4. 3 and 5. 2 and 6. 1 and 7. 0 and 8. They always add up to 8. The number of the exponents always add up to 8. That makes life easy for some of the things we're going to do. And also helps you check to make sure you did it correctly. Okay? So we've gotten the exponents on the variables. What we need to do now is figure out where do those coefficients come from. That's what those little lines are indicating. We need a number in front of each of these. Where do those numbers come from? Now, for the coefficients, there's a shortcut, and the shortcut is called Pascal's triangle. And here is what Pascal's triangle looks like. First row has a 1, second row has 2 1s, Third row has 1, 2, 1. That's not 121. Okay, that's 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. Oops, went really fast. Okay, we'll come back to it in a minute. The pattern then is to add two adjacent numbers, and that gives you the number between them in the next line. Okay, it's clear as mud. Let's look at this triangle again. First row has a 1, second row has 2 1s. Third row, 1 plus 1 is 2. So you have a 2 between the 2 1s, and you have 1s on the end. You always have 1s on the end. The next row, you add 1 and 2 and get 3, and you add 2 and 1 and you get 3. Next row, you add 1 and 3 to get 4, 3 and 3 get 6, 3 and 1 to get 4. So you see how each line builds on the line before it by adding adjacent numbers. 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5. 1 and 5 is 6, 5 and 10 is 15, 10 and 10 is 20, 10 and 5 is 15, 5 and 1 is 6. So that makes Pascal's triangle. You could keep on doing that forever. Okay, you're not going to have to do it forever, but you can. You could keep on going and do that forever. Okay, and if you look at page 472 in your book, they try to illustrate this in numerous ways to try to help you see some of the things I've been trying to explain. So these give you, down at the bottom of the section of the page especially, it's helpful. These give us the coefficients that we need to finish our expanded binomial. You remember we had all those blanks. We're going to get the numbers to put in those blanks from Pascal's triangle, except we actually need 2 more lines in the triangle, because if you'll notice in the book, they show us that they've only gone down to a plus b to the 6th, and we need to go all the way to the 8th to do ours. So I added 2 more lines. These are not in your book, but they're easily gotten from your book. So you have 1, 6, 15, 20, 15, 6, 1. We had done that one already. 1 and 6 is 7, 6 and 15 is 21, 15 and 20 is 35, 20 and 15 is 35, 15 and 6 is 21, 6 and 1 is 7. The next row, same way, 1, 8, 28, 56, 70, 56, 28, 8, 1. Try that on double speed. Okay, that's the 9th row of the triangle, which gives us the coefficients for a power to the 8th. You always have to go up 1 row. So the first row is to the 0. So the second row is to the first power, and the 9th row is to the 8th power. So we take those numbers off Pascal's triangle and drop it into the stuff we already had with the coefficient, with the variables and their exponents. So now we have 1 a to the 8th, 8 a7b, a to the 7th b, plus 28 a to the 6th b squared, plus 56 a to the 5th b cubed, plus 70 a to the 4th b to the 4th, plus 56 a cubed b to the 5th, plus 28 a squared b to the 6th, plus 8 a b to the 7th, plus 1 b 8th. Now obviously we normally wouldn't write the ones, but I did it in here to illustrate the point. Okay, if this feels overwhelming to you, go back, follow in your book, go back through this section, and hopefully it makes sense to you. It really is cool. It really is a powerful tool. Now, they're going to allow us to do something else. So, for example, what if they ask us for the 5th term in a plus b to the 7th? Okay, well, the exponent on a would be 7, 6, 5, 4, 3. How do I do that? What's the 5th term? And remember, in the first term, it's going to be the highest exponent, which in this case is 7. So the exponent on the first term would be 7, second term would be 6, third term would be 5, fourth term would be 4, and fifth term would be 3. So that's a cubed. Now remember, in every term, the exponents add up to 7. So 7 minus 3 is 4, so b to the 4th. Now, this is where Pascal's triangle really is powerful. This is to the 7th, so we pick the row from Pascal's triangle that's for the 7th power, and the 5th term in there is 35, okay? And you can see that I highlighted it. So 1, 7, 21, 35, 35, that's the 5th one. So 35 a cubed b to the 4th, and we're done. Okay, that's really cool, because if you were trying to get the 5th term doing it through multiplication, you'd have to do an awful lot of work. This saves us a lot of work. All right, well, I hope that goes well for you. Good luck on your lesson, and have a good day.